It's my pleasure today to introduce our speaker for the day, Dr. Walker F. Todd. Dr. Todd has a PhD in French from Columbia University and a Juris Doctorate from Boston University. That means he's a paradox. He's a member of the bar in several state courts, the 2nd, 6th, and 10th Circuit Courts of Appeal, and the US Supreme Court. For 20 years, he worked as an attorney and legal officer for the legal departments of the Federal Reserve Banks of New York and Cleveland. Dr. Todd has published extensively in the areas of law and economics and is a recognized expert on the legal history of central banking. In 1981, he was a member of the negotiating team which helped arrange for the release of US hostages from Iran. Currently, Dr. Todd is an attorney and economic consultant in Ohio. In 2007, in his role as a research fellow with the American Institute for Economic Research, he organized and co-edited a conference on scientific, economic, and policy issues involved in the global warming debate. The presenters were an even mix of scientists and economists. The proceedings of this meeting were published in 2008, and much of his talk today will focus on that proceedings of that conference. For the last 10 years, Dr. Todd has served as an instructor in the Chautauqua Special Studies program. That's what we were chatting about earlier. So he's familiar with the Chautauqua setting. And his topic will be gaining a better understanding of climate change. So if we're ready, are we ready, Zach? So we please welcome Dr. Walker F. Todd.
Okay, thank you. Let me get rid of that. Okay, I can share a screen now, correct?
Yes, please.
Yeah, okay. Let me show you this brief clip. It's in French, but the photos are what I wanted you to see. This is from the French newspaper Le Monde, which has they generally have the best photos. I guess they're Agence France Presse photos, but they're the best I have found in the journalistic world that appear online. So the storms that soaked us about a week or 10 days ago gradually moved across the North Atlantic and decided to settle in Western Germany in the Rhineland-Palatinate area. So Belgium, Eastern Netherlands, Western Germany, and eventually Southern Germany and Austria were affected by torrential flooding late last week. So eventually the storms keep moving on, and here they are showing up in China. This is in Zhengzhou, a large city, 10 million people, about 400 miles south of Beijing. So those who've forgotten all your French from school, says torrential rains have swept through the Chinese metropolis of Zhengzhou on the 20th of July. And let's just watch it for a moment. It flooded the subway. According to the Chinese authorities, these storms are the strongest ever recorded in this region. At least 12 persons died in the storm. $200,000 evacuated. In 3 days, Henan province received 1 year's worth of rain. So another drama is menacing the city of Luoyang, east of Zhengzhou. An important local dam can give way at any instant, soldiers warned on Tuesday. Okay, the end of that. All right. So let me get out of that. So this is why climate change either matters or is about to matter quite a lot. It seems that modern society is ill-equipped to cope with rapid and unforeseen changes in the weather. And the question is, how great are these changes going to be? How persistent are they going to be? And can we do anything about it, whether we, mankind, caused the problem or not? And it's that causation that I think, based on the old conference, the 2007 conference that I ran, and more recent controversies, and we'll get into some of them in a moment. But it's that causation that seems to be the biggest bone of scientific contention. Strategies for mitigation, strategies for adaptation and remediation about climate change. These are a little more settled, a little more certain. At least we know what some of the choices are, and more, I think the discussion is more rational. It's when you get to the question of causation. Did humankind do it? That's where the sharpest bones of contention are. So what do we know scientifically about climate change? That's what we'll be talking about for the next hour. I will leave time for questions and discussion, and you'll see as we get about halfway through the slide presentation that we got to discuss what's on the slide. So you'll have ample time to weigh in here. The scientific presenters that I used in the 2007 conference included 2 MIT professors who also worked at Woods Hole, the Oceanographic Institute that is run by MIT on the south end of Cape Cod. So these 2 professors, who are considered the world's leading experts on ocean surface temperatures, ocean currents, and also the other professor was the leading expert on tropical atmospheric cloud formation. If you're worried about global warming, that's where it all begins. His argument is it's clouds that form in the tropical troposphere and then migrate with the ocean currents and the air currents above them. That's where the storms come from. So that's why that matters. We also had a prominent American geologist, and his research involved measuring ground surface and near subsurface temperatures. Hurricane formation expert meteorologist from the University of Colorado Boulder in Colorado State, and a nuclear engineer from Oak Ridge on the role of nuclear power in energy generation without carbon emissions. You might ask, why is the National Hurricane Center in a place like Colorado? Why there? And the answer is, going back 20 or 30 years, the government decided to build a monster supercomputer that would be made available to the National Oceanic and Atmospheric Administration to run mathematical model simulations and try to figure out what was happening with storms as they progressed. So the supercomputer was, I think it's in Boulder, and because of that, the leading experts on hurricanes tend to be at Colorado State and the University of Colorado Boulder. So that's why they were there. Afterward, I'll ask the fellows who arranged this, Bob Spiritus and Bob Hopper, to make available these slides to you if they can. If you're interested, you can send me an email after today, and I can send it back to you as a file attachment. But there is a link to the PDF version of the conference proceedings. It's about 150 pages. But if you follow that link, you'll get to it. It was published here, that's the reference. The formal title was A Global Warming Debate, Science, Economics, and Policy, and this is a partial list of the presenters. So what did we learn from the conference? Let me move that. And I'd say the main challenge today is to ascertain what, if anything, has changed in what we thought we knew then, 2007, on our scientific knowledge or assessment of the feasible and sustainable remedial measures regarding climate change. These are key words to focus on. If you want to do something about climate change, is it feasible? For example, some have proposed that we could adopt the Amish way of life, go back to the horse and buggy, give up the internal combustion engine, and that would really help a lot. But is it feasible in the modern world to live like the Amish? I know a lot about the Amish because I live in a county in Northeast Ohio that has a large Amish settlement about 15 miles east of us. And we interact with the Amish communities all the time, as do you at Chautauqua. There's a large Amish settlement east of you at Casadega, for example. When you're talking about remedial measures, besides being feasible, the next question is, are they sustainable? Suppose you adopted some kind of grand mechanical process to try to deal with climate change.
Oh, try the link again. I think it's in.
I hear someone in the background, by the way. You might want to make sure you're muted. But anyway, you might have to make sure that the grand mechanical process could be sustainable over time. Would people be willing to keep paying for it 5 years, 10 years, 50 years into the future? As an illustration, the Dutch have for centuries been coping with the equivalent of a climate disaster. They have reclaimed land from the North Sea, and besides, the whole western half of the country is pretty much below sea level. So they have to keep the water out. So they have built an elaborate system of dams and dikes, holding basins and so on. And they know that this is crucial to the existence of the nation. And so generation after generation, the Dutch have been willing to keep up the dikes. You know Americans as well as I do. Do you think we would be willing to do that generation after generation? So worry about feasibility, and sustainability. My contention is, oh boy. There. My contention is that based on scientific evidence alone, we have not increased our certainty about what is happening or what to do about it more than incrementally over the last 14 years. In other words, if you took the state of knowledge in 2007 and compare it to what we know about climate change today, how much objective progress has there been, really? And I'd say 10, 15, maybe 20% better knowledge today than it was then. But note that 10, 14 years later, that's only 1 or 2% a year. So our progress here is incremental. It's not as though there's been a revolution and we do a 50% gain in a single year. So I want to summarize below the main takeaways from that conference. And also, as it so happened when I was preparing the talk, I looked through the literature at the last moment and found that Gary Yohe had just written a Scientific American review of the new book by Stephen Koonin, Unsettled, which is about climate change. So the second half of this talk will be devoted to the discussion between Yohe and Koonin. Okay. And another important thing for scientists to remember going forward is, as you're looking at this comparison of the 07 arguments to 2021 arguments, is there new evidence that can be tested or observed and replicated in experimental data in an experimental environment, or where new observations tend to confirm the observations we already had compiled? The usual tests for scientific evidence. Have those tests been followed? Are we confident in what those tests seem to be showing? Here is the reference to the Scientific American article. The title of the article by Yohe was "A New Book Manages to Get Climate Science Badly Wrong." So who is this Gary Yohe? There he is. He's at Wesleyan University in Connecticut. He was a member of the UN credentialed Intergovernmental Panel on Climate Change, the IPCC, and he was a member of that panel from 1990 until 2014. He was one of the founders of that panel. And here is a reference again to the book by Koonin, which has become a bestseller. It's called Unsettled: What Climate Change Science Tells Us, What It Doesn't, and Why It Matters. And Koonin is focusing on what do we know and how certain are we that we know it, and what are you going to do about it anyway if you do know these things. Okay, let's plunge in on my 07 conference. Here were the main takeaways from that conference. We asked Professor Carl Wunsch at MIT. He's the one who's the expert on ocean currents and ocean surface temperatures. We asked him to open the conference with an assessment of where we stood then on a 1 to 10 scale of scientific knowledge about various aspects of climate change, 10 being pure guesswork and 1 being scientific and scientific certainty. So in other words, an inverted scale, the best score being a 1. His overall assessment of the state of knowledge at the time was 3 or 4, with a finding of 2+ or better being required to justify government-directed mandatory action. We were close, but not quite there at the time, in other words. So keep this in mind as we go through these slides. Wunsch's standard, and I thought it was a good one. He and I had extensive talks about how to present this, and we agreed this was a good way of getting the message across, that we had enough observations as of 07 to be reasonably certain that climate change was happening, that human activity may have had something to do with it, and that human action could do something to remedy it. But the state of our knowledge at the time was only a 3 or a 4 on that 10 scale. But before you start pushing people around, government mandated action and the like, you want more certainty than that. You need a finding of 2+ or better. A 2 would be even better. A 1+ would be really good. It's like an A-. And rare are those instances where the state of knowledge would warrant a 1. So what about the Wunsch specialties? What's going on the ocean? He thought ocean surface temperatures were increasing on average and probably would affect ocean currents. but also that scientific knowledge was too fragmentary to undertake direct action to reduce those temperatures, like scattering iron filings on the ocean surface to darken and lower the temperature of the ocean.
But I can't stop being concerned. So.
Here, I hear people, by the way, in the background, so just alert, make sure you're muted. The couple of key points here. There was a news story yesterday that on this very subject, saying essentially that the consensus today, and this is different from 14 years ago, consensus today is that ocean temperatures in some regions are increasing, but in others they are decreasing. And average ocean temperature globally might be slightly cooler than it was in 2007. The flip side, and we'll get to it in another slide, the flip side is that on the land, the surface temperatures of the ground and the near subsurface of the earth, those surface temperatures are warmer than they were 14 years ago. So you see that reflected in the current record or near record temperature readings in places like Death Valley and the California desert. This reference about scattering iron filings on the ocean's surface is problematic. A few years ago, I think it was about 5 years ago, a rich person on the West Coast who may or may not have had Silicon Valley connections hired an airplane to carry a load of iron filings up above the North Pacific and scatter them on the ocean. He did it. A private actor went out there and scattered iron filings on the ocean. You want to pause and think about that a moment. Do you want to authorize private individuals to act on behalf of all the rest of us by doing something like that? I don't know what happened to him afterward. I didn't follow the story that closely. But this is the kind of idea that people will come up with if you say climate change is a serious problem. We need to do something about it immediately. There have been similar proposals to scatter crystals of one kind or another in the upper atmosphere to induce more clouds on the theory that this would shield us from the sun and cool it off a little. And there are rival theorists who say that a cloud layer would tend to trap the heat emanating from the earth and make it warmer, and we don't want that. So there are problems on both sides of that. And there are others who have said we could deploy satellites carrying what amounts to large umbrellas and position them so that it would shield partially the sun's light from reaching the earth, and that should lower the temperature. Again, do you really want to do that? But the question to think about on this slide is, should Jeffrey Bezos on his next flight on Blue Origin, should he scatter iron filings on the North Pacific? And here's this discussion of the ground. Professor David Chapman, a Utah State geologist, measured ground surface and near subsurface temperatures. I think he was drilling holes as deep as 200 feet to see what the temperature was like down there. His conclusion was, yes, surface temperatures on the ground are warming. Audience comments, however, were to the effect that solar or volcanic activity could be as plausible an explanation as climate change for increasing ground temperature. So weighing all the evidence, we considered this more or less a draw. It seemed like a reasonable confirmation of climate change, global warming on the surface of the ground. And we'd give, however, the overall question a 4 on Professor Winch's 10 scale. because of the possibility that solar or volcanic activity could be the explanation. Let me pause there and let you guys, I'm going to hit the stop sharing button for a moment. And let the audience weigh in on what you've heard so far. There's a lot more to come, of course. We're about a third of the way through. But does anyone have a question or comment you'd like to share at this point?
Would anybody like to make a comment from the audience at this point? Got the mic here. Yeah, we have someone in the back, just a second. And can you check to see if we have anything in the chat room?
You mentioned that person who scattered iron filings on the ocean spent a great deal of money doing this. Was this part of a bona fide scientific experiment? And if so, what was the outcome? What results or conclusions were drawn from that?
Yeah, my recollection of the story was that it was not part of an organized scientific experiment. That example I gave you was something like Jeff Bezos takes a load of iron filings up on his next flight and dumps them over the Pacific Ocean just because he felt like it. But this fellow was so worried about climate change and he thought the government wasn't doing enough that he was going to take it into his own hands and cool off the Pacific on his own. Of course, dumping iron filings in the ocean has other consequences. Who knows what it does to sea life and things of that sort. Yeah, it's the.
I have a question.
Yeah, go ahead.
You talk about surface temperature, ground surface temperature. How thick of a layer are you talking about when you talk about ground surface temperature?
Right. The fellow who was doing the measuring was just actually measuring the ground and drilling holes, but his deepest hole was around 200 feet. Okay.
Thank you.
I mean, I have friends who've been involved in oil exploration with Schlumberger, for example, and they drill deep holes and they go down, 5,000, 10,000 feet. But yeah, it gets a little warmer the farther down you go. There, for a limited amount, let's say it's 80 up on the surface, and you go down 50 feet or 100 feet, it might be cooler. Let's say at 50, 55 degrees down there. But as you keep getting into deep holes, the layer below that is warmer as you get closer to the center of the earth. Remember that if you go deep enough, there's lava down there. So everything is much warmer the farther down you go. But the real question is human life, animal life, vegetable life. These are all primarily affected by the surface temperature, what's happening right there on the surface. And what's happening way down below, that can be affected by earthquakes, volcanic activity, and the like. While what's going on the surface is going to be primarily solar or climate.
Anyone else? Okay.
Yeah.
Let me try to get over there and get to you.
Let's do one more and then we'll move on.
Yeah. Take one more.
Real close, all right. Can you hear me? Yes, I guess you
Yeah.
can. Since the 1890s, at least, the U.S. government, either as the National Weather Service or its predecessor, has been collecting temperature data, rainfall data, heating degree data, and the data is readily available and published. Has anyone done just a strict statistical analysis through linear regression or time series analysis on that data?
Yeah, that's commonly done. I mean, meteorologists study that in school and grad school. So their conclusion is average annual temperature is increasing in the United States. Is it increasing in the tropics? Not necessarily. Is it increasing in Arctic regions and subarctic regions? Yes, the real area of concern currently is Arctic and subarctic, where there is actual melting of permafrost, and that has other consequences. If you melt the permafrost, it releases a huge amount of methane into the atmosphere, and methane is a far more worrisome greenhouse gas than carbon dioxide. So I remember at the time of the conference, we asked Professor Linzen, the other MIT professor, what are the big greenhouse gases? And he said, in this order, water vapor, methane, carbon dioxide. So those are the main greenhouse gases that you're concerned with. And so the issue would be, it's going to be warmer in Cleveland, Chautauqua, and Chicago in the winters especially than it has been in the past. Already there are climate-related planting advisories for gardeners and farmers here in Northeast Ohio, saying that we might be able going forward to plant trees and the like that would survive the winter as well as they would in Nashville, just because of the degree of warming we've experienced here. The real question scientifically is that something human activity has created, or is it a natural cyclical phenomenon of the weather which moves in ever increasing patterns? There can be 17-year cycles related to solar activity, for example. And then there appear to be 60 or so cycles, and then 100-year cycles and 500-year cycles, and so on out. So for the time being, the idea is it's getting warmer in the North Temperate Zone where we live, and it's getting worryingly warmer in the Arctic and subarctic regions. That's the general conclusion. But if you ask somebody in the tropics, they might say it's wetter than it used to be, but it's not warmer.
Okay, that's all the questions I see.
All right. Okay, let's go back to share screen and continue. Okay. What about the meteorologists? And I got into this in part because I'm an amateur meteorologist myself. When I was in high school, I think it was a junior, I managed to get myself into the Westinghouse science competition. Won 3rd place in the state science fair with a project I had been doing since I was about 12 years old, essentially keeping detailed daily weather records at my home in Murfreesboro, Tennessee. So anyway, I've been following it for a long time. We had 2 meteorologists from the National Hurricane Center, and we had a 3rd whose name I have forgotten, from the University of Colorado Boulder, who was fairly well known. And he had to do it by conference call because his wife had been injured in an event in Oxford, England, and so he couldn't come. But anyway, the meteorologists thought perceptions of climate change reflect short-term views of long-term phenomena, like what I was just talking about. Long duration patterns, like there was a moderate period in medieval times from around the year 1000 to around 1400, and then a cooler period in Europe that followed roughly from 1400 to 1800. And we've been in a moderately warmer cycle since around 1800. Professor Gray, who was an older gentleman at the time, Professor Gray was outspoken in ascribing climate change to solar activity. He expected the then prevalent perceptions of warming to reverse around 2011 or 2012. And he thought it was tied to 17-year sunspot and solar activity cycles. We're about halfway through that now, so that if we have been cooling, we should be reaching the bottom. And the bad news is that it's going to get warmer from here for the next decade or so. Conclusion, if the sun did it, government mandates will avail little. This is the King-Canute problem. Can the king go down to the ocean and command the waves to stop? Can the government tell the sun, you're causing all of this global warming, we want you to stop? So what's the evidence on the meteorological side? Because of the strong views, one side and the other, I think we decided to assign it about a 4 on the Carl Wunsch rating scale. Reasonable idea that it's solar activity driving climate change. It's a reasonable idea, but there are other possible explanations. One meteorologist, in fact, said that he thought it was volcanic activity more than anything else that had caused the warming in recent decades. And indeed, there does seem there's more volcanic activity than there has been. One of the problems about volcanoes, though, is they tend to be in remote locations, and they could be erupting and you wouldn't necessarily know it. So this is a question of observational bias, where you have more people out around volcanoes now. They report more frequent eruptions, but maybe they're only erupting about the same way they did for the last 100 or 200 years. It's just that we're noticing it now. Another theory advanced by one of the meteorologists was, at the time, around 2007, he said, we're moving into a planetary alignment where the 5 or 6 planets closest to the sun are all strung out more or less in a string perpendicular to the sun. And this rarely happens. It does happen occasionally, but he thought that gravitational forces generated by the moon and planets was tugging magma within the Earth's mantle in one direction or another. And that in turn would feed the volcanic activity that we've been observing. And it was related to gravitational pull of the planets. So all kinds of theories show up on this one. I'll deal with this and then we can ask for a question again. What about the IPCC itself? It's been treated as the ultimate spokesman on all things climate change for years now.
What is the IPCC?
IPCC is a UN appointed body that was created back in 1990. Gary Yohe, whom I was quoting, was a member of the original panel. And it had scientists from all over the world on it. It's the Intergovernmental Panel on Climate Change. And we asked Claudia Rossett, who used to cover the UN for the Wall Street Journal, to come and talk. And her assessment was the UN was more interested then and now in political correctness than in scientific objectivity in paneling the IPCC. I think you have to work with international agencies to understand the thrust of this criticism. You might say, isn't it a good thing to have international agencies trying to resolve global problems? And the answer is probably yes. The problem always arises. These bodies tend to become entrenched and political. I have done missions for the World Bank in various countries, for example, on loan from the Fed. And you'd say, is the World Bank political? And I would say, yeah, it's intensely political, but it's better than the IMF, okay, International Monetary Fund. And the IPCC has some of the same problems. We also asked Professor Richard Nelson, a biologist at the University of Maryland, to describe what he thought was the case for climate change skeptics at the time versus the mainstream of the scientific community. And he said, well, they do treat skeptics as theological heretics. And to be a skeptic, you can be a skeptic on various things. You can deny that the phenomena are happening. Nobody does that very much. Or you can deny that mankind caused it. And there might be something to that argument. But anyway, Professor Nelson's viewpoint was more or less saying the IPCC is like the Curia of cardinals in Rome, and all skeptics are treated as heretics in the scientific community. So we gave the IPCC the benefit of the doubt, and we award them a 3 on the Wunsch scale. We're basically saying, there we are. We're basically saying that what I said before, that the evidence is there are climate changes. The only question about them is, are they long lasting? Are they sustainable? Can we do anything about them? And the skepticism arises on, is human activity creating the problem in the first place, or are these natural, long-lasting, cyclical phenomena? We had a presentation on taxation as a means out of the wilderness, path out of the wilderness. Kenneth Green, an economist and a policy analyst at the American Enterprise Institute, explained cap and trade schemes that assign companies right to pollute warrants up to given limits. Those warrants then can be traded. In economic theory, those who value the warrants the most will pay the highest prices for them. And such schemes have been around for a while. They're widespread in Europe. I think California has such a scheme for energy companies. They've been around for a couple of decades. But in Europe, when these cap and trade schemes related to global warming, when they were first introduced in the 90s, General Electric, Goldman Sachs, and Morgan Stanley rushed to create the largest trading platforms for such warrants. Now, how many of you think that those companies, GE, Goldman, and Morgan Stanley, had the future of mankind as the foremost objective in their hearts, as opposed to making money? Well, carbon trading started out at about $15 a ton. That's how much it costs to produce a ton of carbon emissions. That's how much you would pay for that right. And they've gotten up to around $50 in Europe. I think it's on the next slide, but the current thinking is, unless something happens, if they keep pushing the cap and trade scheme, the price would go as high as $100 in Europe. And this is an outrageous level. economic activity would come to a stop if the price got that high. Cap and trade appeals to those who favor a command and control view of the government. This is the King-Canute approach. We hereby want pollution to stop. We order it to stop. Well, you implement that with a cap and trade approach. But we economists think that increasingly a carbon tax would make more sense than cap and trade. You might say, well, where do Republicans stand on this? And the answer is, if you're one of the managers, big shareholders in one of these companies, you like cap and trade. If you like option and derivative games in the stock market, you would like cap and trade. But if your objective is just get carbon down to the lowest possible level consistent with economic activity, you want a tax. The tax would be on all carbon emitters, or all those who are emitting above a certain level. And that would be more effective in reducing carbon emissions than cap and trade. And there I gave the example of you start out at $15 a ton and increase the tax as needed. But in Europe, the tax might have to go as high as $100 to be effective. China and other developing nations generate a lot of carbon emissions and would need a low tax, at least initially. That's India, China, and others. Right now, it's estimated that developing economies, India and China primarily, generate about a quarter of all the carbon emissions in the world. We, the US, generate about 25% of carbon emissions for the world, but we also have 25% of global GDP. So it would be effective to have a carbon tax in the United States, but it would work better if other countries, including China and India, had the tax too. And at this moment, there are international negotiations going on with that objective, trying to reach a common goal of an internationally enforced carbon tax. It would be enforced at the national level, not by the United Nations or some international body. Who would get the tax money? National jurisdictions, US Treasury in our case. What would happen to the money? Well, the UN is going to ask for some of it to be directed to developing and climate change endangered nations, island nations like Vanuatu that are worried about disappearing under the waves and so on. So we would give the carbon tax a 1+ on the Wunsch scale. It's a good idea. It's not perfect. It doesn't get a 1, but it gets a 1+. And the best you can say for it, at least, is it beats cap and trade. And this is unfortunate because people knew this 14 years ago. And we've essentially wasted 14 years pursuing cap and trade scheme, largely because of the push of the big money boys, the Goldman Sachs's and GE's of the world. So we've been concentrating on cap and trade when we should have been doing the carbon tax all along. You've essentially lost 14 years of progress by pursuing the wrong solution. And that's a useful lesson to remember as you choose among various solutions going forward for this problem. Capstone of our conference was actually Professor Lindson's talk. So Richard Lindzen of MIT, who's the leading authority on cloud formation in the tropical troposphere. The troposphere is the middle layer of the atmosphere. He proposed a carbon tax linked directly to scientific observations of temperatures in the tropical troposphere. That's the region of the atmosphere where most storms begin. And he pointed out, if scientific observation shows the temperatures are rising, then the tax can be raised. But if the temperature falls, then the tax should be reduced. But proponents of strict climate change countermeasures tend not to like the second part of Lenzon's proposal. They want the government to order the temperature to go down and take steps to see that it does instead. Lenzon's idea, remember, was, hey, if the temperature is going down up there, we'll lower the tax. The problem is dissipating. But there are people who want to eliminate carbon dioxide emissions generally, regardless of their effect on surface temperatures. So you got to figure out how to deal with that viewpoint before you could accomplish Lenzon's idea. But we all liked Lenzon's idea at the conference. We'd give it a 1+ or a 2- at worst on the Wunsch scale. In any case, it would cross the threshold where we would say it's an idea that's good enough to warrant government action. What about nuclear? We had an Oak Ridge nuclear engineer talking about the role of atomic energy in a carbon neutral world. I forgot the fellow's name. His paper was not in the conference proceedings, but his main point was continuation and even expansion of atomic power generation seems inevitable in the future if your aim is rapid reduction of carbon emissions. There is no alternative power source that replaces so much carbon-based power in so short a time. Here in Ohio, if you said, I want to phase out all the coal generating plants in the power system of Ohio, and I want to do it tomorrow morning, what's your alternative? And the answer is fire up the 4 or so nuclear plants that we have that are in the process of being shut down or mothballed. If you want to give up coal, you got to adopt atomic until the alternative sources like wind and solar can be scaled up sufficiently. So the evidence for this idea, we thought, was at least a 1+ on the Wunsch scale, something that ought to be acted upon. And we pause there. We've got about 10 minutes left. I'll take more questions. That's the end of our conference, but you can see we were talking about most of the things that are still on the climate change agenda 14 years later. And the main difference between then and now is my point about wasting 14 years pursuing cap and trade solutions instead of doing a carbon tax. We'd be way ahead in the game if we had had a carbon tax starting 14 years ago. But questions out there?
Well, first a comment. You're now the second speaker we've had this season who suggested that if there is an intention to reduce the amount of carbon emitted, that the carbon tax is the best approach. So
yes, somehow this finally started getting traction among Democrats. Republicans have been supporting it in Washington for a while, and now at last there seems to be bipartisan support for the idea.
What can we do as individuals, like driving zero emission cars, other steps that we as persons can do?
Do as I did and buy a hybrid car, that helps. If nothing else, even if all you're driving is a traditional hybrid where it's half gas, half electric, you're at least cutting your emissions by 1/3, and that helps. um, is a brief comment on that. I'm a skeptic about the transition to an all-electric automobile fleet in the next 10 to 20 years. Because I live in Ohio and I have to drive to New York City, I have to drive to Tennessee, and sometimes I drive to places like Colorado, New Mexico, or Montana. And I just don't see electric getting me there. While I have a Ford Fusion hybrid, and I can drive that car to Montana without any concerns at all. So I think it's the way to go, and probably for the long haul truck fleet and things like that over time, that's the way we'll wind up having to go, is switch to hybrids. The sooner the better.
Dr. Todd, I appreciated your comment about observational bias. And I'm worried. Several years ago, we had a journalist speak to us on the coming instability and climate change, a guy named Eugene Linden, who wrote a wonderful book about it. One of the things he pointed out is that we can and must learn from the past.
Wow.
And on temperature, there are pilings that are taken in Greenland and in nice icy places that can tell you what temperature was like eons ago. I worry that as we're letting all of that melt, we're destroying one of the archives of our history. And nobody's talking about that.
Right. I think there's nothing other than running out there and drilling all you can to get those core samples today. There's not much you can do in Siberia, Western Antarctica, parts of Greenland. Ironically, in parts of Greenland, it seems that the snowpack is increasing each year. Other parts of Greenland, it's melting. But I think your concern is a legitimate one, that the core samples we have relied on to predict the future from looking at the past, those core samples may not be available to us in a few years, and we need to preserve as many of them as we can. Pardon me.
So you have about 5 minutes to wrap up. You want to keep going?
Yeah, let me switch back. Look at Gary Yohe's arguments, the current controversy with Stephen Koonin. So this just came out. It was posted on the Scientific American website on May 13th. Yohe essentially says that Koonin is arguing, remember that Yohe was an original member of the IPCC. So Yohe says Koonin is arguing that, as in 07, the science of climate change is still unsettled. Professor Wunsch would say, repeating this, that the evidence then was a 3 or a 4, but you need 2+ or better to justify having governmental mandates. So I think Yohe believes that the evidence today is stronger than 2+, and he wants the activity and the mandates, but he does not attempt to quantify his evidence. I think Wunsch would give him a 3, not quite over the threshold yet, based on the article that just appeared in Scientific American. So here's one of Yohe's arguments. He says, this is not to say that uncertainty is being eliminated about climate change, but decision makers have become more comfortable dealing with the inevitable residuals. Our discussion just now of the carbon tax versus cap and trade is a good illustration of that. 15 years ago, nobody wanted to hear about carbon tax. Now, when you explain to them that it's better than cap and trade, they will listen to you. But anyway, so policymakers are using the best and most honest science to inform prospective investments in abatement like reducing greenhouse gas emissions to diminish the estimated likelihood of dangerous climate change impact, and adaptation, reducing vulnerability to diminish current and projected consequences. I'd give this argument about a 2+ on the Bunch scale. That is, mild governmental action is now warranted, aimed primarily at abatement, reducing greenhouse gas, go buy a hybrid, or adaptation, reducing your vulnerability. And there, that can involve things like, well, if you live in a flood zone, maybe you ought to move out. About a third of Brooklyn is in a zone that would be subject to serious flooding in the event of major storms. We discovered the hard way a few years ago that lower Manhattan is also similarly vulnerable. So either you spend the money to build high dikes, as the Dutch have done for centuries, or you move people out. And in the Mississippi River Valley, the government has been doing that to a lot of towns that are subject to flooding. Just buy out the town and move people out of there. This will probably be the last one we have time for. What about heat waves? And the answer is, as we know in the West, we're having monster heat waves, heat bubbles. But the comment was, if heat waves are no more common than they were in 1900 and the warmest temperatures in the US have not risen in the last 50 years, that's a quote from Kunin's book. This is a questionable statement depending on the definition of heat wave, and so it is really uninformative. Heat waves are poor indicators of heat stress. Whether or not they're more frequent, they have clearly become hotter and longer over the past few decades, but populations have grown more vulnerable in large measure because they're on average older. Nighttime temperatures are increasing most, and people never get relief from insufferable heat, and more of them are at risk of dying. We'll stop sharing. I want to talk about that. I don't think that heat waves are necessarily worse now than they were when I was young. I remember growing up in Tennessee in the mid-1950s, and there were photos in the newspaper of people over in the nearby town, Franklin, frying eggs on the sidewalk. And temperature from 54 to 58 in the summer was really extreme. It got up well above 100 and stayed there throughout most of the summer. And this rarely happens in Tennessee. Previously, there had been super cold winters. The last monster winter we had in Cleveland was in 78. But we've had a few that have approached it, but none that have exceeded it. So I reject the idea that the weather is demonstrably worse today than it has been. I think it was bad all along. It comes cyclically. And our task there is just adaptation or abatement. Either we improve cooling systems for the summer, heating for the winter, and just adapt to what is coming at us rather than trying to change the whole climate. Well, I'll have to stop there. I've got 10:01, so I'll hand it back to Bob Spiritus.
Thank you, Dr. Todd. I want to make a few announcements. Next week, Dr. David Katz will be talking about advances in functional medicine, and he too will be zoomed in. So it'll be the same kind of situation that we've had today. You're welcome to come here or to pick up our Zoom link, but to get our Zoom link, you need to register. So there, if you look at the Chautauquan, it will give you that information, or just grab one of us and we'll give it to you after this is over. And as Bob Haber likes to say, this year we do have some expenses because of the Institute's cutting back on letting us use places for free and giving us support for free. So we'd appreciate it if you drop a few dollars in the kitty in the basket in the back. So let's thank Dr. Todd. and appreciate his presentation. And I had forgotten to ask you the question, but you answered it. I think you're willing to let us take your presentation and put it on our website,
Yes,
and that the links to the document that you've referred to is something that's open to the public also.
yeah, those should be generally available, like even our 07 conference. That's in the archives at Great Barrington. So I think if you just copy that link and put it in your browser, it will lead you there.
Yeah, it'll be in your speech, so that the slides will be in the speech. So if you want to try to get information that has been referred to, that should be available on our website. So thank you for coming.
Yeah,
We look forward to seeing all of you, and we thank Dr. Todd for his presentation all the way from Ohio. So
okay,
and
thank you.
thank Teresa and Zach.